about today is how we can use case studies in severe weather evaluation. And this material is mainly based on an ECMWF technical memorandum I published last year. But to start with some background thoughts. And the first one is why do we do forecast evaluation in the first place? And one can see it as a two-folded problem, because at least working at the Forecasting Institute, we want to make evaluation in order to guide future forecast system development, so to find deficiencies in our current system. But the other part is to inform users about the capabilities of the current forecasting system. And these are two different aspects, and they share some evaluation metrics, but quite often one need to evaluate forecast in different ways for those different purposes. Then the other problem that I usually start with is because we want to use ensemble forecast as the main tool for prediction of high impact weather. But the problem is that a single probabilistic forecast for this type of life-threatening events cannot be verified. So why do I make this statement? So first of all, we do not know the true probability distribution function at the forecast time. And in the end, we only get a single outcome. So we cannot verify the reliability aspect, like the ensemble spread, for a single forecast. The next one is that to overcome that, we need to have a large statistical sample to build on. But then the problem is that the life-threatening events are usually rare, and we often talk about return periods above 20 years, which means that if we want to look at the current forecasting system we have, that we use for around a year before we do the next upgrade, we got a far too small sample to do a proper probabilistic verification. And then these type of life-threatening events are usually composites of sub-events, and they are unique in the horizontal and temporal scale. So you can think of it that we need a series of precipitation events during a longer period leading up to a major river flooding. And then for coastal flooding, it's usually a combination of waves, storm surge, tides, and the inland precipitation that ultimately give the flooding, and then the length and magnitude of heat waves. So instead, what can we do? So first of all, we can do a statistical verification, but lower our threshold to what we consider extreme in order to get a good sample size. Then we can also evaluate the model climatology. So how well can the model in a climatological sense capture the tails of the climate distribution? So do we have a frequency bias, for example? And then we can finally learn about important aspects from case studies that we can further dig into. That is what I'm going to highlight in this presentation. So in order to do this work, we have, for a number of years now, run a severe event catalog. And we have about 130 cases over the past 7-8 years. And the purpose for this is to collect material to do forecast evaluation, but also to look into new forecasting products, use them for further model experimentation, and also facilitate the communication on severe events to our users. And once every quarter we use a case from this catalog for a newsletter article, and this starts to be a quite good library now. I think it's 25, 26 articles in a row in the ECMWF newsletters we put together about extreme events. So to show you what type of different aspects we can pick up from a case, I will use a recent example, which is the extratropical cyclone Alex that hit actually most part of Western Europe in the first days of October this year. So this is almost at midnight in the end of the 1st of October, where we had the cyclone center just off the coast of Brittany in France. And it had a stingjet-like feature in the backbending front with wind gusts reaching 50 meters per second. And then quite a far away from the cyclone center. So the cyclone center stayed over the Bay of Biscay up to the British Isles for a couple of days, but quite far away over the southern Alps, the same cyclone system caused very extreme rainfall, and one station actually observed more than 600 millimeters in 24 hours. And in the plot to the right, you can see the distribution of 24-hour precipitation or observations on that day. So on different timescales, what was governing this extremes? And we'll focus on the precipitation aspect. And on the plots here to the left, you see what we call the Extreme Forecast Index, which is a product we use at ECMWF to compare the ensemble distribution with the distribution of the climatology for each point and calculate an index to see how extreme it is. And if we start with the one-day forecast, verifying on the 2nd of October, to no surprise, we see very large values, close to 1 over the southwestern Alps. And I also included here Extreme Forecast Index for the integrated water vapor flux, which indicates the transport of water vapor. And we see that we had a very strong moisture transport onto the Alps on this day. So if we go back 5 days before the event, we see the 2 plots to the bottom, and we see that the forecast picked up the broad scale risk of a wet day in Western Europe, but it's not so coming out so extreme over the Alps. And if we look at the moisture transport, we see that it's have a more westerly component instead of southwesterly that we saw in the one-day forecast. And to look at the moisture transport, I also calculated the backward trajectories from ECMWF analysis for trajectories ending up on the 2nd of October, close to the French-Italian Mediterranean coast. And the coloring here is the specific humidity. And we see that the trajectories picked up most of the humidity over the Mediterranean, and that the fetch almost got the maximum length, starting from south of Spain and going towards France and Italy. So here the exact position of the cyclone leading to this transport seems to have been important. And even if we picked up the cyclone on the in the 5-day forecast, the exact position did that we missed the extreme, which we can see on the forecast evolution plot in the top left corner, where compared to the model climate in red, we predicted a wet day, but not outside the 99th percentile, and we see in the MPO that was far out. So if we look at the evaluation of the short range prediction and focusing on the Alps, we see that even if we inside this box over northern Italy predicted truly extreme, so the ensemble median was 130 millimeters, it was far from the average of all the observations inside the box, which was 230 millimeters. So factors that needs to be considered here is both the interaction with the orography and where the resolution plays a role. So here I included our HRS forecast with 9 kilometers and our control forecast with 18 kilometers. And we see that we get, for this short range forecast, this 1-day forecast, we get a little bit higher peaks in the rainfall. But another factor is during the fetch of these trajectories leading up to the event, whether we got the right evaporation and moistening of the air. So what we have done for quite a few of different type of extreme cases is then to try to list what are the important factors on different time scales. And for this type of flash floods in Europe, when you want to look into extended range, 2 to 4 weeks, we're talking about regime or this type of troughs over the Mediterranean area. And I put a question mark because we do not know yet whether these are predictable or not on this time scale. Then in the medium range, it's more about the exact position of the trough or cutoff low that determines the steering flow and the atmospheric rivers reaching towards the Alps. And then in the short range, the evaporation and the moisture advection and also precipitation processes in relation to orography. So by using this type of case studies, we then can come up with factors that we need to do a further evaluation on. And I'm discussing this more in the technical memorandum. So this then brings to the next step in the value chain. And I also included this picture with the different mountains. And from an evaluation perspective, we want to know how the value of the information propagates downstream, going from our precipitation forecast, and then how to modulate hazards, like in this case, a flash flood product from the Copernicus Emergency Service, and then leading into a warning. And then is the tricky point how to verify the impact and how to use that information. So to finishing off with this, what we want to know then from this evaluation is which forecast range is most useful for this high weather forecast application, and how is the forecast information used, and how can we improve our forecast system. I'll stop there and take questions.
Okay, Linus, thank you very much. We have time for a few questions for you, I guess. So, Martin, what's going on in the chat?
Not a lot of questions for Linus so far.
Maybe then
go ahead.
Maybe let me go ahead and ask one. Well, I was curious. So, for example, if you look at the statistics of the ensemble, for example, now in your upper right-hand corner here, this distribution, this is the unstressed ensemble. So there's no post-processing applied to it. Is that correct?
Yes.
And if yes, do you know how the picture would change if you applied post-processing, particularly for, say, the orographic precipitation in Italy? Probably the statistics would know that orography is still underrepresented.
So it's a good question. One type of post-processing where the DCMWF is to scale it down to represent point rainfall to get the how is the distribution looking within this grid cell. But in this diagnostic, I have averaged over a number of grid cells, and the number of observations going into the average value is a couple of hundreds. So it's rather downscaling is upscaling, and it still points to an underestimation for this case. But we made a study a couple of years ago looking into the underestimation of orographic precipitation, and then afterwards a change in the moist physics went in, which made it better. So I don't have the exact answer in the top of my head how much we underestimate on average this type of precipitation events.
Okay, thank you, Linus. Martin?
No specific comment question. Brian Golding made the comment. I think that's always important to remind everyone that another reason for evaluation is to justify investment, of course. That's true for ECMWF, but I guess true for every weather service. And another comment that I wanted to make is that Linus is also involved into the new SARA high weather value chain project. So we're looking forward to get your expert opinion in that. There's one question coming in from Jimmy regarding forecast range for high impact weather. What decisions are needed locally? Yeah, what did you find in your evaluation, research, that what decisions were helpful locally, or is it from an ECMWF basis? Did you not go into local feedback?
So I think that's where we really want to get information out from this value chain evaluation to see what type of decisions are happening based on the forecasts and on the different time ranges. And for example, if one have a type of decision 5 to 7 days ahead, that is a relatively cheap decision compared to the gain. So one have a low cost loss ratio, then one can add on a quite small probability, it's a small risk, and still gain. So that's why even that one can have benefits in the medium range. But that's where I hope in the high weather project that we can get information more from the user side, which can help us in our evaluation.
And maybe a last question, Linda from the University of Reading asks, how are you defining useful in your final slide?
our toolbox of metrics, I would probably look at the potential economical values, looking in for specific cost loss ratios to see how the whether the forecast has a positive economical value. That would be the first type of metric to look into.
Okay, thank you so much.
Okay, thank you, Martin, again for entertaining the questions. And with that, I would like to start coming to a close to the webinar. I would like to thank all the attendees for listening. I hope the presentations were of great interest to you and helpful for your own work. Thank you very much for everybody that participated by asking questions in the chat. And of course, last but not least, thank you very much to all of the speakers. Now imagine clapping hands and a cheering audience to give you proper credits. I would like to remind everybody about a high weather workshop taking place next week on the 3 days. Be reminded also on the high weather website, which unfortunately is not a net slide, but which is just highweather.net. If you're interested in high weather, if you're interested in activities of the processes and predictability and process team, if you're interested to join and contribute, please get in contact. All the contact information you'll find on highweather.net. And with that, thanks again, everybody. Have a good evening, a good rest of the day, a good night, wherever you may be. Bye.